Hey, welcome back everyone. This is the Delta Workbook, and today we're starting the next unit, Unit 16, which is all about decimals, fractions and percentages. It's Mr. Rostraya here, and this is Lesson 1. Today we're going to be converting fractions to recurring decimals. If you haven't done so already, just pause the video and have a go at question number 1. Okay, question number 1, we're adding. We've got decimals, so the first thing to do is write the larger value on top. It's £23.49. Next, whenever you're adding or subtracting decimals, put those decimal points in line and put them in before you do any working out. That removes the chance of you forgetting them at the end and losing the vital marks once you've done the hard bit. Now we've got £7.82, £7.82. Now we're ready to add. 9 add 2, 11, carry the 1. 1 add 4, 5, add 8, 13, carry the 1. 1 add 3, 4, add 7, 11, carry the 1, and then we've got 3, including our units as well. So the final answer there, £31.31. Our next question, we've got 2 with a small 6 above it. That means 2 to the power of 6. Now we know 2 squared, or 2 to the power of 2, is 2 multiplied by 2. 2 cubed is 2 multiplied by 2 multiplied by 2. That's 2 to the power of 3. So 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. So let's work out bit by bit. 2 times 2, that gives us 4. Multiply that by 2 again, we get 8. Multiply that by 2, 16, then 32, and then 64. So 2 to the power of 6 is equal to 64. That is your final answer, 64. Okay, we've now got an equation to solve. We've got 5x minus 1 is equal to 34. So let's write out the equation. 5x minus 1 equals 34. Okay, what we're trying to do is get x equal to a number on its own. That's what we want. So first thing I need to do is get rid of this negative 1. Now when I say get rid, I mean turn to 0. So imagine you're on a number line. How are you going to get from minus 1 to 0? You will have to add 1. And to keep our equation balanced, we must always do the same thing to both sides. So we need to add 1 to this side as well. So if we've got 5x minus 1 add 1, the minus 1 and add 1 will cancel out. We're only going to be left with 5x on this side. I then need to do 34, add 1, and I get 35. Next thing I need to do is get from 5x to 1x. How am I going to do that? I'll do that by dividing by 5. To keep my equation balanced, I must divide the other side by 5 as well. 5x divided by 5 gives you that single x that we wanted. Okay, that is an x. And now we do the same to the other side. 35 divided by 5 gives you 7. So the final answer there, x is equal to 7. Okay, next we've been asked to round to one significant figure. One significant figure is your first significant figure. That's the 5. That is the first significant figure. That's the second, the third, the fourth, and the fifth. So if we're rounding to one significant figure, we need to look at the significant figure after that to tell us whether we're going to round up or whether it's going to stay the same. 5 and above, we give it a shove. So we're going to give that 5 a shove up to a 6, and all of the other values will turn to 0. So that's going to be 60,000. Okay, next, we've got negative 7 plus 9. Whenever you've got negative numbers, it's always helpful to think about a number line. If 0 is here on my number line, negative 7 will be down here. If we're adding 9, that means we're going up our number line. We need to go up 9. So from negative 7 to 0, we've gone up 7 there. So from 7 to 9, we need to go up an additional 2. So the final answer there, minus 7 plus 9 is just 2. It's positive 2, but you do not need to write the plus sign there. That is just positive 2. Okay, then we've got the nth term. I'm going to start by writing the values out. We've got 12, 14, 16, and 18. I then need to work out what is going on here. What's the common difference? What is the rule for this sequence? Well, I can see they're all going up by 2 each time. That means we've got a form of the 2 times table, and we found the first part of our nth term, 2n. I now need to write that 2 times table below and work out how do I get from the values in my 2 times table to the actual values in my sequence. From 2 to 12, we add 10. Does that work from 4 to 14? Yes, it does. 6 to 16 and 8 to 18. So we found the second part of our nth term here that we are adding 10. Okay, next, let's have a look at some examples. So the example that they've given you here is of 3/11ths. Now, 3/11ths, what that actually means, 3/11ths, is literally 3 divided by 11. And what you get out is this long number, 0.272727. That will keep going on for infinity. And we don't want to keep writing that for infinity. So what we do is we use these little symbols here, and they tell us what numbers will continue on for infinity, what numbers are recurring. So 3/11ths, once we do 3 divided by 11, we get this long number. So we can say that that is equivalent to 0.27 recurring. I'm going to show you some of the other examples that we're going to come across throughout this lesson as well. One of the examples you may have seen before is this, 0.3 recurring. Okay. You wouldn't write it like that. You would write 0.3 with this dot above it. And that dot tells us that that 3 will go on and on and on for infinity. Another example we might see, you can do that in green, is this one, 0.12. This is very similar to our 2/7 example we saw at the top there. Okay, and that's going to be 0.121212. That will go on and on and on and on. We might also have this one here. So we've got 1.3, 4, 5. And if you have 2 dots here, the first dot is going to be the first recurring digit, and the last dot will be the last recurring digit, and everything in between will also be recurring. So what that will actually look like, if you wrote it out in full, would be 0.345345345 for infinity. Okay. The final one that I'm going to show you as well, just going to do that up here, is when some of the digits at the beginning, they don't actually recur. That might look something like this. If you've got 0.678, but you've only got the recurring symbol here and here, you would still have that 0.6 at the start, but the only recurring digits are going to be the 7 and the 8. So it goes 7, 8, 7, 8, 7, 8 after that on for infinity. Okay. How do you get from the fraction to a decimal? You need to remember that the sign in the fraction, I'm just going to write this simple example here, this literally means 1 divided by 2. That line in the fraction, that means divided by in mathematics. Hopefully you all know that 1 divided by 2, or 1/2, is equivalent to 0.5. The reason why 1/2 is equivalent to 0.5 is if you do 1 divided into 2 by 2, you will get 0.5. So that's what we're going to be doing for the fractions here. In the example they've got here, 3/11ths, they've done 3 divided by 11 to work out its decimal value. Okay. So to find out a fraction as a decimal, you divide the top, the numerator, by the bottom, the denominator. Let's have a go at some of the main questions now. Right, so this first one, we've been asked to write 6/11ths as a recurring decimal, and we do that by doing 6, the numerator, the top, divided by 11, the denominator, the bottom. And we're going to do that using the bus stop method. So the number we are dividing is 6. That means 6 goes inside our bus stop. Okay, the inside of your bus stop is for the number that you're dividing. Now 6, we could say is the same as 6.000. You could add as many zeros as you like over here, it's still 6. We're dividing that by 11, so that goes outside our bus stop. I now need to think how many 11s can I fit into 6? So the 11 times table is going to be key here. I can't fit any 11s in 6, so I put a 0 there. My decimal point will stay in the same place, and I now need to join that 6 up to the 0. Some of you might write it like this, but as you're going to see later on in the activity, it can get very confusing laying out your work like this. So what we want to do instead is carry our 6 over and write it like this. So we've now got 60 here. How many 11s can fit into 60? Well, 11 times 5 gets us to 55. From 55 to 60, we have a remainder of 5. We're now thinking how many 11s fit into 50? Well, 11 times 4 gives me 44. And from 44 up to 50, what was my remainder? It was 6. We've got 60 again. How many 11s fit into 60? Well, 5 gave us 55 with a remainder of 5. And as you can see, we're just going to keep getting 5, 4, 5, 4, 5, 4. So the answer to this is 0.54, and that will keep going on forever. They are the recurring digits. Because the 5 and the 4 are both recurring, you'll need your decimal point, sorry, not your decimal point, you will need your recurring point above both of these, the 5 and the 4. Let's have a look at example number 2. I'm going to do all of question 2A to D in black, then we'll go E to H in another colour, I to L in another colour, and then we'll do question 3 separately as well. So we're now looking at question 2A to D. A, B, C, and D. Okay then, 2A, 1/3. That is 1 divided by 3. So the number you're dividing, 1, goes inside your bus stop. The number you're dividing by, 3, goes outside your bus stop. And we put our decimal points in, because 1 is the same as 1.0000. And you've got your decimal point in the same position above as well. How many 3's can we fit into 1? None. So we join those up. And we now think how many 3's can fit into 10, because we carried that one over. We can fit 3 3's into 10. That gives us 9. From 9 to 10, we have a remainder of 1. How many 3's can we fit into 10? And as you can see, this is just going to keep going on and on and on. So we found 1/3 is 0.3 recurring. That 3 will continue on forever. It's recurring, so you need your dot above the 3. Next, we've got 1/9. 1 divided by 9. How many 9's can we fit into 1? None. So we carry the 1 over. How many 9's can you fit into 10? You can fit 1 with a remainder of 1. How many 9's can you fit into 10? 1 with a remainder of 1. So that will continue forever. We're going to have 0.1 recurring. Okay, that is the digit that will continue on. Next, C, we've got 1/12. 1 divided by 12. We're dividing by 12. And we are dividing 1 by 12. Okay, how many 12's fit into 1? None. So we need to carry that 1 over. We've now got 10. How many 12's can fit into 10? You can't do that either. This is why we want you to carry the digits over rather than doing lines like this, because it can get very confusing when you start doing that. We're now looking at how many 12's can fit into 100. So you need your 12 times table in your head. None can fit into 10. And at 12 times 8, that gets us very close. That gets us to 96. Anything more than that, we go above 100. So 12 times 8 got us to 96. From 96 to 100, what is the remainder? The remainder is 4. How many 12's can fit into 40 now? Well, 12 times 3 gets us to 36. So from 36 to 40, what is our remainder? 4. So as you can see, we've now found our recurring digit. It's going to be this 3 recurring. Okay, so 1/12 is the same as 0.3 0, 8, 3. The 3 is the only digit there that is recurring. So it's the only digit that will have the point on top. We've now got 4 ninths. 4 divided by 9. So the number we're dividing inside our bus stop, number you're dividing by outside your bus stop. Okay, how many 9s fit into 4? None. So how many fit into 40? 9 times 4 gives us 36. What is the remainder from 36 to 40? The remainder is 4. How many 9s go into 40? Well, 4 9s get us 36. And this is going to go on and on and on. So here, going to have 0.4 recurring. Now you may notice a bit of a pattern here. In question B, we had 1 ninth, and that was 0.1 recurring. In question D, we had 4 ninths, 0.4 recurring. So I'm sure some of you can make some predictions. What do you think 5 ninths would be? Well, 5 ninths, that will be 0.5 recurring, and so on. Okay then, let's have a look now at questions E to H. Questions E to H. And like with the ninths, some of these, the more you see, your brains will just be able to recognize them. Okay, if you've got 1 ninth, 0.1 recurring, 2 ninths, 0.2 recurring, and so on, you'll start to see a few more of these as we go through the activity. Okay, so we're now on questions E to H. So I've got E here, F, G, and H. Okay then, 1/6. So we're doing 1 divided by 6. Okay, how many 6s fit into 1? None. And we've got a decimal point. Now we carry that 1 over. How many 6s fit into 10? 1 with a remainder of 4. How many 6s fit into 40? Well, 6 times 6 gets us to 36, and we've got a remainder of 4. So this will just be repeating on and on and on. So 1/6, that's going to be 0.16. 6 is the only recurring digit there. F, 1/11. So we're doing 1 divided by 11. How many 11s fit into 1? None. How many 11s fit into 10? None as well. So we need to carry that 10 over, and we're now on 100. How many 11s fit into 100? Well, 11 times 9 gets us very close to 99. So we've got a remainder of 1. How many 11s fit into 10? None. So we need to take that whole 10 over. How many 11s fit into 9? And we've got back to this again. Okay, so this would keep on happening again and again and again. We've got 0.09. Both the 0 and the 9 are recurring. So you're going to need your point on top of both digits because it goes 0, 9, 0, 9, 0, 9. Next, we've got 2/3. For this one, we saw earlier that 1/3 was 0.3 recurring. Therefore, 2/3 will be 2 lots of that. It's just going to be 0.6 recurring. Of course, you could get there using the bus stop method as well, 2 divided by 3. But this is another one of those key fractions that you will see over and over and over again, and your brains will just be able to recognize the more of these that you do. Okay, H. We had 4 11ths, 4 divided by 11. So do a bus stop. We're dividing 4 by 11. How many 11s fit into 4? None. We've got a decimal point. And we carry the 4 over. How many 11s fit into 40? 11 times 3 gets us to 33. What is the remainder from 33 to 40? 7. How many 11s fit into 70? 6 gets us to 66. And then we've got a remainder of 4 from 66 to 70. Some of you might have spotted it already, but how many 11s go into 40? Got 3, 33 with a remainder of 6. Sorry, with a remainder of 4. apologies, let's go back to that. How many 11s fit into 40? 3 gets us to 33. We have a remainder here of 7. Okay, then how many 11s fitted into 70? It was back to 6 again. Okay, so we can see here that we've got the 3 and the 6 as our recurring digits there. Equals 0.36. They are recurring. Okay then, now ready to have a look at questions I to L. I to L. And we're going to do these in green. Okay then, so we've got I to L. Okay then, let's have a look at the first one, 7/15. So that is 7 divided by 15. We're dividing 7, and we are dividing that by 15. Okay, how many 15s fit into 7? None, so we carry the 7 over. How many 15s fit into 70? Well, 15 times 2, 30, then 45, 60, 75 would be too high. So 15 times 4, that got us to 60. From 60 to 70, we had a remainder of 10. We're now thinking, how many 15s go into 100? Well, 15 times 6 gets us to 90. And then we've got a remainder of 10 again. And we're just going to keep getting this pattern recurring on and on and on. So we found there, that's going to be 0.46. 6 is the only repeating or recurring digit. So that's the only one that you have your dot above. Next, 5/6. That is 5 divided by 6. The number we are dividing is 5. The number we're dividing it by is 6. Okay, how many 6s go into 5? None. So we carry that 5 over. How many 6s go into 50? Well, 6 times 8 is 48. And we've got a remainder from 48 to 50 of 2. How many 6s go into 20? Well, 6 times 3 gets us to 18. From 18 to 20, we have a remainder of 2. And we're just going to get this 3, 3, 3, 3, 3. So we found that. That is going to be 0.83 recurring. Okay, we're on K now. 4 divided by 15. So the number we're dividing is 4. And the number you're dividing that by, 15. Okay, how many 15s fit into 4? None. So we carry the 4 over. How many 15s fit into 40? Well, 2 times 15 gets us 30. And then we have a remainder of 10. And it's similar to the, or was it question I? Now we can see we've got that 100 again. 15 times 6 gets you to 90. So then you've got a remainder of 10. And this will continue on and on. So we found 4/15. That's 0.26 recurring. Okay, L. 7/9. That is 7 divided by 9. Hey, how many 9s fit into 7? None. So we must carry that 7 over. How many 9s fit into 70? Well, 9 times 7, that gets us close to 63. And then we have a remainder of 7 again. So this will just continue on and on. So 7/9, 0.7. And then if you have a look back at question B and question D, a 1/9, 0.1 recurring, 4/9, 0.4 recurring. We've got another one here, 7/9, just 0.7 recurring. Okay, and that was the final question of question 2. Now moving on to the last question here, question 3. Now question 3, the numbers are a little larger. So that means there's going to be a bit more working out. If you prefer, you can use the long method. Okay, you can do long division. I'm going to stick with short division today with the bus stop method. Okay, 11 divided by 30. So we're now doing question 3A. 11 divided by 30. So The number I'm dividing is 11. And the number I'm dividing that by is 30. Okay, so here I really need the 30 times tables in my head. How many 30s can we fit into 11? Sorry, well, how many 30s can we fit into 1? None. How many 30s can we fit into 11? None as well. So we've now got 110 here, and I need to do my 30 times table until I get up to 110. I could use my knowledge of the 3 times table though to help me, and imagine these as 3 and 11. Okay, so we've got 30, 60, 90, 120 would be too large. So 30 times 3, that gets us to 90, and I've got a remainder of 20. I now need to think, how many 30s can I fit in 200? Well, 3 times 6 gives me 18, so 30 times 6 will give me 180. From 180 to 200, what is my remainder? Well, my remainder is 20 again. Okay, so this 6 will just keep recurring, keep continuing. Okay, so that is 0, don't need the double naught there, it's just 0.36 recurring. Okay, next, B. We've got 28 divided by 45. So the number we're dividing is 28. And the number we're dividing that by is 45. So here you want your 45 times table in your head. To make things a little easier for myself, I'm just going to write down the first few digits in the 45 times table. 90, 135. And this will just help me out a bit rather than having to do the 45 times table mentally every single time for each part of this question here. So how many 45s can we fit into 2? None. How many can we fit into 28? None. How many can we fit into 280? That's where writing out our 45 times table can really help here. I can see, I've just about done enough there. Anything more than that would be in 315. That would be too large. So how many 45s got me to 270? It was 1, 2, 3, 4, 5, 6. So 6 lots of 45 got me to 270. From 270 to 280, my remainder was 10. I now need to think, how many 45s can I fit into 100? Well, 2 lots of 45 gets me to 90. So my remainder again will be 10, and this will continue on. Okay, so here we've got noughts. Oh, I forgot my decimal place because I didn't put that in at the start there. It's really important that you're making sure you're doing that right at the start so you don't forget it at the end after you've done all of that hard work. So this is 0.62, and the 2 is the recurring digit there. Okay, I'm just going to rub this out and give myself more space for this next one. We've got 47 divided by 90, and this is for part C. Okay, so the number I'm dividing is 47, and the number I'm dividing that by is 90. Now you could write down your 90 times table here, or you could use your knowledge of the 9 times table to help you. I'm going to do that. How many 90s can we fit into 4? None. How many can we fit into 47? None. So we're now on 470. We're carrying both that the 4 and the 7 from 47 over. So 9 times 5 gives me 45. So 90 times 5 will get me 450. From 450 to 470, that's a remainder of 20. Okay. 9 times what gives you 20? You could use that here to really help you. 9 times 2 gives you 180. So 9 times 20, sorry, 9 times 2 gives you 18. So 9 times 20 will give you 180. From 180 to 200, we have a remainder of 20 again. So this is just going to keep happening again and again and again. And that will keep recurring on for infinity. So 47 divided by 90, or 47/90ths, will give you 0.52 recurring. Okay, let's have a look at D. So we've got 27 divided by 110. So 27 inside my bus stop, because that's a number I'm dividing. And I'm dividing that by 110. So I'm going to write my 110 times table down here, just to make things a little easier for us. We've got 220. Yeah. You could also use your knowledge of the 11 times table to help you out as well. Right then, let's have a go here. 110, how many times does that fit into 2? It fits no times. How many times does it fit into 27? None. We've got our decimal point. And we've now got 270. How many 110s can we fit into 270? We can fit 2. That got us to 220. From 220 to 270, we've got a remainder of 50. So we're now looking at how many 110s fit into 500. Well, 110 times 4 gets us to 440. From 440 to 500, we have a remainder of 60. Okay. Now, how many 110s fit into 600? Well, 510s, that got us to 550. From 550, I'm just going to give myself a little more space here. From 550 to 600, we had a remainder of 50. Okay. Something's looking familiar again, because I've done this before. How many 110s can fit into 500? We can see from earlier that we fitted 4 in. That got us to 440, and our remainder was 60. So we're back at this again. We've got the 4 and the 5 that will keep on recurring. So the final answer there is 0.245. The dots will only go above the 4 and the 5 because they are the only recurring digits. It's 0.245 with the 4 and the 5 recurring. Okay guys, that was the end of lesson 1, and we were converting fractions into recurring decimals. Next lesson, we're going to be doing the reverse of that. If any of you want to extend yourselves a little bit further and to try some of the more challenging examples, particularly like some of the examples we saw here in red, then have a go at the Hegarty task here. 74. 73 will be very similar to the ones that we were just doing. 74 will be a bit more challenging. And then the Corbett Maths textbook exercise will be a really good way to push yourself even further. Okay, I'll see you next lesson, guys.